All right, so let's take a look at some alternative implementations. We'll first look at one implementation, which will be perfectly fine. Right? There won't be anything wrong with this implementation. But then we'll look at an alternative implementation, right? And then compare and say, well, it looks like we were done, right? What other way could there be to implement this, right? And we'll see some caveats on this particular implementation and how it could be improved somewhat. All right. All right, so let's take a look at our first implementation. Right, so having looked at some of the assumptions and having met with our client folks that we're building this library for, and there was a lot of talk of some canonical way of representing this using hours, minutes, and seconds. We've been discussing this quite a bit. So we agree that perhaps the best way that we can represent the idea of time is to use 4 integers, 1 for hours, 1 for minutes, and 1 for seconds. Right? We decided on this. It sounded like a reasonable way to represent the durations. Also notice the naming convention. We decided to say, well, this is the implementation of the duration interface. So we appended the impl, IMPL, to the duration, right? So that it's clear that this is implementing that interface. It's a little bit foretelling that we're naming it IMPL as if this were the only implementation. Right, we say this is the implementation of this duration interface, as if there were no other implementation. Right. So oftentimes we might add some caveats or parts of this naming convention. We might put maybe a default impl. Right. We might say this is duration default impl, meaning this is the default implementation. If you don't want to use any other specific or alternative implementation, this would be the default implementation. Yes. Later on, we'll see another implementation. We'll call it the compact implementation, right? A compact duration, which will look at this from a different point of view, and we'll revisit the naming that we chose for this, right? It says, well, why do we even call this DurationImpl if there was yet 2 or 3 or 4 additional implementations, right? So the naming should also capture that idea, right? That this might not be the only implementation, right? Although it's a fairly good first start, right? All right, notice that we are making the class final, right? We're also making all these private. We're making it private, right? Implementing the fact that this is information hiding, and also we're making these variables final as well. Another thing that we're doing. One of the choices that we've made is that we are making this class final. Right? This class final, meaning that nobody's going to be able to inherit from this. Okay? And not that there's anything wrong with inheritance. It's just we want to have control over that. Right? If we know that this is intended to be inherited, then it's fine. We'll remove the final. Right? But as a default, right, we want to have control over that, and a good start is to just declare as final. Right? Yes. Yeah, we'll talk about that in a minute. Yep. So first of all, we are controlling the inheritance. Inheritance has its own challenges, right? Of folks inheriting from us and having access to our content, and we have no control over the inheritance. So to get started with, we'll start by discouraging, or at least not allowing by default folks to be able to inherit from this, right? Inheritance can add its own complexities, right? Of having to add additional constructors, having constructors have to access to the super class and things like that. So just to limit the complexity, right, we're going to disallow or discourage the inheritance, unless we identify any benefit to having folks inherit from this base class. Okay. The other is that we're declaring these to be private fields, right? That making use of the information hiding principle, that nobody should have access to the implementation. I should be free to make different declarations or how I represent my data internally. From the outside, any implementation decisions on implementation should be opaque to anybody outside, right? They shouldn't have access to any of my variables. These should all be private. So we're going to prevent any access to these fields only through the official interface that we provide, right? Any accessors that we might provide, always through this official interface, right? Nobody should be access to it. Now, to start off, we're going to, if we need to give access to any particular field, we'll add getters, or we'll provide setters and getters for that particular field if needed, right? If they have read-only access, then we'll only provide the getters. If they also have write access to a particular field, we'll also provide the setters, yes? But only in a need base, right? If we need to provide read-write access to any one particular field, right? But by default, we'll start off with making private, and by default, not providing the setters getters only when is needed or we see any benefit to making it available. And to your question, we're also going to make all these fields final, right? Meaning we're going to as much as we can, we're going to try and make our objects to be immutable, right? So that they cannot change over time. They can be set only at the beginning, right? They can be initialized, saying that this almost treated like a constant, right? That has these values. It represents this particular time and particular moment in time, right? And that makes it so much easier to test, right? Yes.
Is that because, like, say you do like an addition of two durations?
Yep.
You're just going to make a new duration.
Exactly. We're going to instantiate a brand new duration. Yeah, so mutation has its own challenges. It's so much easier to test something that does not change over time, right? The example that I gave yesterday of for instance, testing an ATM account, right? That you first have to initialize a particular state, and it's so much easier to test something that doesn't change over time, right? If it changes over time, I have to make sure that I know the original state. That if I apply a particular method that I call on it, or a particular stimuli, then I can know then what the transformation is from one state to another. It just complicates things, right? And this is not true only for these simple examples that we have, right? This is true in a much broader sense, right? Stateless things are so much easier to test, to implement, to maintain. I mean, even for instance, we always drive this even in server programming or middle tier programming, or even front end programming. We always drive folks to implement things that are stateless. Right? It's so much easier to test a React or Angular or whatever component that is stateless. Right? That if you give it this JSON data, it always renders this way. Right? That it has these buttons, these lists, and whatnot, and so much easier to test. Right? If it changes over time, it's just so much harder. Right? You have to set up the initial state. You have to run these stimuli and see if the DOM changes in a particular way. Same thing for servers. Right? Servers, typically we would like to make them as stateless as possible. Right? If the server needs to remember conversations with thousands of users, and it has to maintain state, well, you have to have more CPU, you have to have more memory. The footprint of your server just increases exponentially. Right? It's so much easier to not maintain any state. You have some token, some cookie, and you go fetch data from the server, and you can reinstantiate the state. Right? And now your footprint for implementation is so much smaller. So stateless. Right? It's always all throughout the architecture is so much better decision. Right? Stateless. Make things stateless. Immutability, right? Things that don't change over time, makes things that are so much more modular. Some advantages of immutability. I should switch to the next slide. Right, it makes things easier to test. If you only have one state, you can very easily just share it and just send it over as a reference, because it's not going to change. It's going to have always the same value. Right? It's also by definition, is thread safe, right? Because it doesn't matter if another thread comes in, because it's not going to be able to change the state, right? It comes in, so you can have multiple threads running at the same time through the same code, right? Because the state is not going to change. So you can have all number of readers and writers in the same code, and it makes the code run much faster, so that you can have multi-threads running simultaneously as opposed to waiting on each other, right? Waiting on the state to change and read and write, right? So it just makes the code so much more efficient. Right. So since we declare all these variables, we declare them as final. They need to be initialized somewhere, right? And the only place that we can initialize it is at the constructor, right? So here's one of the boilerplate constructors. Again, having heard so much from our clients about hours, minutes, and seconds, it looks like a very convenient constructor to have around is one that takes indeed hours, minutes, and seconds, right? And we're going to validate one of our invariants, right, that we declared earlier. We don't accept negative values, and if something goes wrong, if somebody passes something bad for us, we're just going to complain and throw an illegal argument exception that you cannot pass negative values. Did you see exceptions in previously? Yes? Okay. And if this passes, right, we're good to go and initialize our variables to their respective values. So in the constructor we can set the values, validate, set the initial state, and this is the only place where we'll be able to change the state of these variables, only at the constructor level, right? And then never again, right? They behave like constants. If the source code, if anywhere in your source code you try to change these variables, these values, the compiler will let you know, right? It says, nope, you can't do that. You can't change these values, only in the constructor. Right. So we have the constructor. We have initialized the variables, and we try to use it. We start playing. Yes.
When you said you can't change it, is that because of the final?
Yeah, because of the final.
So if there wasn't final, you can change it.
Yes, exactly. Yep. What was I saying? Right. So we have the initial constructor that we built. It seemed pretty innocuous, right? That it accepts hours, minutes, and seconds. It's pretty and initializes our values, hours, minutes, and seconds, and we're good, right? So we start using it. Our client, whoever's writing code that is using our interface and is using our implementation starts using it, and they run into these particular edge cases, right? They set the minutes to 90 minutes, and somewhere else they set 1 hour and 30 minutes, right? So it says, oh, wait a minute. So these are supposed to be equal, right? It's the same amount of seconds, right? It's 180 seconds. So where in our code do we know, do we capture the fact that these two things are the same, right? That there's no, if we compare them today and we compare, a straight comparison of the hours, minutes, and seconds of one representation and an hour, minutes, and seconds some other representation, 90 minutes would not be the same as an hour and 30 minutes, right? Which makes no sense that these would be different. Yes? So nowhere are we capturing the fact that these two particular D1 and D2 are actually the same, right? They should be interpreted the same way. So we need to capture that somewhere, right? So we have a couple of options. One option is that, well, we can implement our own equals, right? Override the default implementation, right? And do some arithmetic, and say, well, let's see, 90 minutes. This is so many seconds, and an hour and 30 minutes is these many other seconds. And look, they're the same amount of minutes. They're the same. Good, they're equal, right? So we would have to implement that, right? We would have to override the equals, and that seems like a fair or reasonable thing to do, right? And we might even go ahead and do that. But then it turns out that we're implementing a couple more operations and comparisons and whatnot, and we find ourselves having to implement the same arithmetic. It says, wait a minute, right? Didn't I do this arithmetic in the equal sign? Maybe I could, perhaps encapsulate that arithmetic in one single place, so it's reusable everywhere, right? As opposed to duplicating this logic of converting all of these things of hours, minutes, and seconds, and realizing that these things are equal, or that I can add them, or I can multiply them, subtract them, whatever, right? All these operations I'm going to have everywhere. I'm going to have this problem of duplicating this arithmetic. So instead or in addition to the equals, perhaps another alternative might be to, well, how about we don't really deal with hours, minutes, and seconds, right? And we transform always down to some canonical representation, right? And perhaps seconds. And we always deal with seconds, right? We never actually deal with hours, minutes, and seconds. We always transform down to the smallest unit representable, right? And we do everything down at this canonical form, right? If we do that, right, then everybody else, the equals and the plus operator and the multiplication, minus, everywhere else, right, we could then write them in terms of this canonical single representation. That makes sense? Right? So again, a couple of considerations on trying to avoid potential duplicate code everywhere, right? And so this might be a principle, right? This might be a principle that what is the canonical representation of whatever data set that you're working on, right? What is the canonical representation, so that we can transform it down to this canonical representation and then do all operations in terms of that single representation, instead of having to convert here and there and have all sorts of edge cases everywhere, right? All sorts of if statements and switch cases everywhere, and instead just deal with this canonical representation. So having realized that it's a better solution to go down the route of the canonical representation, we would revisit our representation, right, of the duration, and say, okay, well, we're not going to deal with minutes, hours, and seconds. Let's convert everything down to seconds, right? So we might write some arithmetic in the constructor, right? We would still initialize our minutes, hours, and seconds, right? But then do the conversions so that we can convert how many hours down to minutes, and then convert all the minutes down to seconds, right? Do some of that conversion and deal with the edge cases only in one single place, right? Deal with if it's bigger than 59, if it's less than that, it's greater than that, and whatnot, right? And do all those validations in one single place in the constructor, right? And so this is a better choice, right, than spreading this logic everywhere, right? And that's basically what object orientation it does, right? That's the whole point of object orientation, right? Before object orientation, we could still do the object orientation without object orientation, right? What we would do is have switch statements all over the place, right? We would have, if it's a square, draw it this way. If it's a circle, draw it this other way. If it's this, that, and the other, right? And we have switch cases everywhere in our source code, right? And having written so many switch cases all over the place, we got tired of it and says, wait a minute, can we having identified this pattern that we need to write the same algorithm but for many different types of things, instead of me writing the switch cases, could I invert that, right, and delegate all that writing of the switch cases? Can I write it in such a way that the compiler does that for me, right? Have the compiler, right, write all those switch cases for me, and give me a syntax that you have a base class, and then you have all these inheritance hierarchy, right? And you say that you have a base class, and then you have this derived class, yes? And I invented the idea of polymorphism, yes? Right? And having this abstract idea of polymorphism, obviously, internally, somebody has to convert it into switch cases, right? And written in from C++ down to compile it down to a bit code that does have all these switch cases, but we're not writing it anymore. The compiler is writing all these things for us. Yes, right. That's the whole point. Same thing here, right? We want to centralize these decisions, right, in one single place, so that we're not writing all these edge cases all over the place in our source code, right? We can centralize it. Right. So this is a better choice. All right. So let's take a look at some of the domain methods, meaning the methods that are needed for our particular domain. In this case, is a duration domain.